Let us now start with the last portion of this chapter, and which is the most important application of this chapter, and that is periodic properties. Periodic properties, right? So what do you mean by periodic properties? Periodic properties are those properties on the basis of which we tend to classify elements based on similarities. Okay, the similarities or the properties in which we find similarities to classify them together, they are called periodic properties. Okay, now we are going to study some periodic properties slowly, and we're going to try to link them, right? So that's why I'm not going to go as per the textbook, same order, because I want to go step by step so that you are able to link the properties together and try to find the basic idea behind them. So let's start. I'm going to start with the effective nuclear charge. Effective nuclear charge. So how do we define effective nuclear charge? Effective nuclear charge is defined as the charge implied by the nucleus of an atom on the outermost electron. So if you have an atom like this and there is an electron outside, then the charge implied by the nucleus on this electron, okay, the charge implied by the nucleus on this electron is known as the effective nuclear charge. Effective nuclear charge. Now, variation of this effective nuclear charge as we go along groups and periods of the periodic table, right? Let's have a look. Now, as we go along the group, so first of all, let's not say group, let's say along a period first. So along a period. So as we go from left to right in a period, okay, as we are going from left to right in a period, okay, the effective nuclear charge increases. The effective nuclear charge increases from left to right. From left to right. This is because the number of electrons in the outermost shell increases, and hence the proton's influence on the outermost electrons also increases. So for example, let's take the second period itself. Okay, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. We don't usually consider the noble gases. Okay, so if you see here, we're going to have 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6, and 2 comma 7. These are the electronic configurations. So now have we look at the number of valence electrons. They are continuously increasing, right? They are increasing. So as this is an increase in the number of valence electrons, the charge on the outermost shell also increases, right? And hence, as we go from left to right in a period, the effective nuclear charge increases. Okay, fine. So I hope along a period, effective nuclear charge variation is absolutely clear. Let's now move down a group. So if we go down a group, what happens? Down a group. Now down a group, what happens? The number of orbits keep increasing, right? The number of orbits in the configuration keep increasing. Hence, the distance of the nucleus from the outermost orbit keeps increasing. Hence, we say that effective nuclear charge, as we go down a group, effective nuclear charge decreases. Charge decreases. This happens as we go down a group. As we go down a group. So let's take an example. Let's take the first group: lithium, sodium, potassium, okay, rubidium. Okay, this many are enough. Now, as we go down, what is happening? The number of your orbits is increasing. So if you see here, the configuration is 2, 1. Here the configuration is 2, 8, 1. Here the configuration is 2, 8, 8, 1. Here the configuration you don't need to know. Okay. So if you see it may be like this: 2, 8, 8, 8, 1. Right? So now if you see, it will be 18. This will be 18. Okay. We write it properly. 18, 18, 1. Now if you see the number of what is increasing, orbits 2, 3, 4 and then 5. So orbits increase, and obviously the distance from the nucleus of the outermost electron increases, hence effective nuclear charge decreases. Okay, so effective nuclear charge down a group, it decreases. Right, so I hope that's absolutely clear. Is there any kind of doubt there? Okay, so I hope that's absolutely clear to all of you, right? So that's with your effective nuclear charge. That's the first periodic property and its variation, right? So now let's move on to the second periodic property that we're going to discuss, and that is atomic size. Atomic size. So what do you call atomic size? Atomic size is basically atomic radius, and it is defined as the distance between the center of the nucleus and the outermost electron. Okay, the distance between the center of the nucleus and the outermost electron and outermost orbit of an isolated gaseous atom. There is no external influence and it is a gaseous atom. So this R is what we call the atomic size or atomic radius. Okay, so that's what we call atomic size. Okay, the distance between the center of the nucleus to the outermost orbit of an isolated gaseous atom. Okay, so that's your atomic size. Now let's have a look at the variation. Before we do that, try to relate atomic size and effective nuclear charge. Now, if effective nuclear charge will be more, that means the protons in the nucleus will be pulling the electrons towards itself, right? And hence, an increase in the effective nuclear charge will result in the compression of the atom, and hence the atomic size will decrease. Hence, you can formulate a relation. Atomic size is inversely proportionate. Atomic size is inversely proportional to the effective nuclear charge. Atomic size is inversely proportional to the effective nuclear charge. Please try to understand it. It's very important. Atomic size is inversely proportional to the effective nuclear charge. So now I think if you've got this relation along group and along period, it's going to be really, really easy, right? So first let's start off with the period, along a period. So if you go from left to right in a period, you know what happens? Your effective nuclear charge increases. Effective nuclear charge increases. And as a result, what will happen? Because you know, if effective nuclear charge is inversely proportional to atomic size and vice versa, then obviously if effective nuclear charge increases, then atomic size will decrease. That's it. So that's absolutely clear. As we go along a period from left to right in a period, the atomic size decreases. For example, let's take an example of one period: lithium, beryllium, boron, carbon, nitrogen, oxygen. Suppose we're taking only this one. So here we go from left to right. You know that your effective nuclear charge, which is denoted by Z star. Okay, this denotes effective nuclear charge. Okay, so Z star increases. Z star increases, and therefore your atomic size your atomic size, what happens to atomic size? It decreases. So oxygen is smaller than lithium, nitrogen is smaller than beryllium, carbon is smaller than boron. Right? So I hope that's absolutely clear to each and every one of you. Is there any kind of doubt? If so, please write it in the section below. Right? Now let's come down a group. Now down a group, it's pretty simple to understand. Why? Let's see. Down a group. Down a group, basically we go down a group and number of orbits increases. Number of orbits increases. As we go down a group, the number of orbits in the configuration, they keep increasing, because you know that as we go down a group, the period numbers keep changing and hence the number of orbits keep increasing. So as the number of orbits increase, obviously the size of the atom will keep increasing. That's pretty obvious to understand. Hence you can say that atomic size increases. Atomic size increases. Right? So for example, lithium, sodium, potassium, rubidium. As I've told you before, the configurations are 2,1, 2,8,1, 2,8,8,1, 2,8,18, 1. Okay. So these are the configurations. Now if you see here, the orbit numbers keep increasing, right? Number of orbits keep increasing. So orbits increase, and since orbits increase, this results in increase in atomic size. Increase in atomic size. Right? So I hope atomic size is also absolutely clear to each and every one of you. So see, I linked atomic size with effective nuclear charge, and you could see that how you were so easily able to relate. So everything is interlinked. That's why I'm going in that particular order. Right? So for now, we are done with today's class. Okay, so that's all for this video on atomic size and effective nuclear charge. In the next video, we will be continuing our periodic properties. Thank you very much.